When simplifying these ones, ultimately I think power to a power multiply is going to be your quickest way. But when you have a negative number, you need to be really careful of the sign. Keep in mind that when you multiply an even amount of negatives together, your final answer is positive. But if you multiply an odd amount of negatives together, your final answer is going to be negative. So before I even start the problem, I typically think to myself, is my final answer going to be negative or positive? And then the power to a power won't let you down. So keeping that in the back of your mind, I'm going to go ahead and use expand. Expanding is our fallback plan because the signs, you usually don't lose a sign and so forth, or if you forget a rule, it's a good place to start. So if I have all of this to the second power, that's really all of that times itself. And then I continue to expand. And this is -7 times y, and then z to the fourth times z times z times z times z. And then again, the same thing. I can multiply in any order I want. So -7 times -7 is 49. And then y times y times y times y is y to the fourth power. And then 1, 2, 3, 4, 5, 6, 7, 8. So I have z to the 8th. But if we use the power to a power, again, make sure you think of what is my sign before you even get started. This -7 is to an even power. So if you have an even amount of negatives, you know your final answer is positive. Emphasizing here the negative, and the exponent on 7 is 1. When I go power to a power multiply, it's -7 in parentheses to the second power. And then 1 times 2 is 2, 2 times 2 is 4, and 4 times 2 is 8. And so -7 times -7 is 49. Okay, so this one here, I'm going to use the shortcut again. But when I use the shortcut, I want to think, what is my final answer? Is it positive or negative? We have the number -2 raised to the 5th power, which means we're multiplying 5 negatives together. And if you have an odd amount of negatives, your final answer is negative. So I have emphasized the negative there. And I'm going to go ahead and just say, I know my answer is negative before I even get started. Power to a power, 1 times 5 is 5. But this is -2 in parentheses to the 5th, not just plain -2 to the 5th. 1 times 5 is 5. And 4 times 5 is 20. And if you multiply -2 times -2 times -2 times -2, however many I said, 5 of those together, I end up getting -32, v to the 5th, u to the 20th. Now, this brings up the most common algebra mistake out there. It's the same problem that plagues even calculus students later. When you pick up your calculator and you intend it to take -2 to the 4th power, and you might even try typing this into your calculator right now and seeing what you get, you might be surprised. If you type in -2 to the 4th power and you hit enter, your calculator is going to give you -16. But you know that -2 times -2 times -2 times -2 is positive. And the reason is you're not telling your calculator what you think you're telling it. If you want the -2 to be squared, I need to put the -2 in parentheses. Because what your calculator sees here is that this is -1 multiplied by 2 to the 4th. -1 times 2 times 2 times 2 times 2, so it gets a negative. Order of operations, say we do exponents before multiplication. So if I write this as -1 multiplied by 2 to the 4th, your calculator is taking 2 to the 4th first and then multiplying by the -1. So if you want the number -2 to the 4th, you've got to put that inside parentheses. And then your calculator is doing -2 times -2 times -2 times -2, which is positive 16. But if you always make sure that the very first thing you do is decide, is your final answer positive or negative? Before you use power to a power, you should be fine. If you have an odd amount of negatives multiplied together, like I have in this one, I know that my answer is negative, and if that was an even exponent, then I would know that my final answer is positive.